You all know why we're here. You want to hear about multithreading, about how it can be made simple or at least less complicated. Because Marco already scared some of you a few sessions before. So I'm here to tell you it's not that bad with the proper tools. So a little introduction. I will present to you some parts of the OmniThreadLibrary, which is add-on for Delphi, an open source library. And I will focus mostly on high-level constructs, the tasks that make multithreading simple for people that don't want to mess with threads and understanding of threads and so on. So what is OmniThreadLibrary? Well, it's my child. When I designed it, I tried to make something that relates to multithreading because VCL relates to the Windows programming. Some of you may remember that in years and years before, you had to write about such long program just to display main window on the screen. And then the Delphi came. And I wanted to do something similar. And I want to allow everybody to get access to low level, to Windows API, to Delphi ST-thread. So you use high level functions, but you can still work at low level when required, if desired. So everything is nicely packed, well tested, and because testing is the biggest problem in multithreaded programming, it hopes to achieve that you can pull a well-tested component and use it, and you don't have to care about it as much. And because David Tai mentioned something about parallel programming, like async and parallel for in future Delphis, I want to show that you can have async and parallel for already today. The project itself is released with the OpenBSD license, which means that you can use it anywhere. You don't have to give any acknowledgements. The only thing you cannot do is take it and tell everybody that you wrote it. That's it. So you can use it, it's free. Actively developed, well alive for 2 years now in version 2.2, which was released 2 weeks ago, I think, with Exit2 support. It requires at least Delphi 2007. It won't work in Delphi 7, no way. And currently works only in Win32, so no 64-bit, but we'll come to that later. So how to install? I won't show the details here. Basically, download, unpack, add to the search path, and add 1 unit or maybe 2 or 3 units. We'll see that later. To use these classes, use this clause, and that's it. So very trivial. So if you go to Google Code and search for OmniThreadLibrary, or if you go to my blog, which is the delphigig.com, or if you just download the slides after the ITDevCon is complete, you'll get the URL here. What about the future? Windows 64 programming, this is very asked about and will come in next month or 2, definitely before the end of the year. And I hope very much that the FireMonkey support will also be included before the end of the year, because there's actually less work to be done on FireMonkey support than it's on the Win64. The trick here is that OmniThreadLibrary uses T-thread for all the threading purposes. So the guys at Embarcadero already did the hard job. I can just build on their stuff. OS X will be implemented, but I don't have a timeline yet. basically because I don't have a Mac, for starters, so that's the first problem. And I don't do any development for Mac, but I want OmniThreadLibrary to work on all supported platforms. So you can use it everywhere, maybe except the iOS. The problem with iOS is that when you write your application in exe2 for iOS, it is at the end compiled by the Free Pascal compiler. And Free Pascal cannot consume OmniThreadLibrary because Free Pascal is basically Delphi 7 syntax-like, syntax-wise, with some additions. But the smart records, the records with functions, which are used very much in the code, won't work in the Free Pascal. So when the Embarcadero releases the new generation compiler for iOS, I have every hopes to change OmniThreadLibrary to work there too. So I will start with some basics. And the most important thing that you have to remember about those basics is that you won't need them, actually. But I will, from time to time, refer to this or that, and it's good that you know what I'm talking about. So the main focus of OmniThreadLibrary is that it moves your attention away from the thread level. You focus on the task, and task is a piece of code that you want to run. You don't care how the thread is created. You just want to run it on a second core, not on the main. You want to run it in parallel. So the main division here is basically you use OmniThreadLibrary by calling create task. This is low-level construct. You give it this code that has to be executed. And this create task will generate two interfaces. One is iOmniTaskControl and one is iOmniTask. So your task now runs in a secondary thread, and it can communicate with this interface back with the owner. And vice versa, the owner can communicate with the task with its copy, its own interface. Well, it's not the same interface, different interface. And as I said, you can still call everything from Win API to tthread stuff here in this code. So you have task, which runs in a thread. That's a big difference. And you have some interfaces which are used for communication. You just remember that. And the second very important part today, second basic low-level component, will be something called T-Omni-Blocking Collection, or the interface version I-Omni-Blocking Collection, which is the same. This is a first-in, first-out queue. Very simple construct, but it was designed especially for multi-threading work. It means that first, there is no locking. You put stuff in, you put stuff out. There's no critical section monitor or such stuff that would block and make you wait. Second, it doesn't care from which thread you call its methods. You can create it in one thread, you can use it in another, you can call add from one thread and take from the second. It will always work. So you can use it without thinking about it. It's a queue that works always. It has a very simple interface. You call add to put stuff in. You call take to take values out. The trick here is that take will block if the queue is empty. So if you have a producer-consumer scenario, one task is putting data in a queue, and another task is taking data from the queue and processing this task. And the consumer gets blocked, so it cannot produce the data. Producer gets blocked. The consumer will call take. Take will find that there's nothing in the queue, and it will just wait. And when there's new data available, the take will automatically be awoken, and the consumer will start processing again. So to stop the consumer, typically call complete adding, which puts the queue into complete state. all the data that is still in and will be read out, but the next time you call take, it will fail when the queue is empty. That's why you basically should always call try take, which is a function returning a Boolean if it was successful or not. Or you use a simple for in construct. You just say for value in queue, and it will process everything, and then it will jump out. Very simple. And what is stored in this queue is something called t-omni-value, which is a very variant-like record. It takes 16 bytes. It can contain everything from strings to object interfaces. It can store exceptions and so on and so on. Why something new? Why not variant? Why not t-value? Well, t-value was added too late. This code works in 2007. And t-value is terribly slow on some occasions. Variant was simply not powerful enough. And again, it's under some occasions too slow. So this is the fastest and most powerful and most compatible solution I could find. Okay, so this brings me back to the focus of my talk. So forget this. You don't have to deal with tasks, with threads. You want to deal with algorithms. So Marco mentioned this quote 2 sessions ago, and this is very true. Multithreading is terribly hard. I'm working on this area for years now, and decades maybe, and I get beaten from time to time. It's terribly, terribly hard. So a year ago, in some other presentation, I displayed this slide to scare the people. And this is all true. Designing is hard, writing is hard, testing is hard, and debugging is nightmare. And high-level constructs, which I'm showing today, try to take some of this pain away. And we'll see at the end what can be simplified and what still you have to care for. So what I will be talking about are the following constructs, which you can think about them as language features which are not built in the language yet. Maybe they will be, maybe they will not, but they try to function almost as a language feature. So the first one is async. That's very similar to the create anonymous thread the new Delphi has, 2009 and newer, I think. So you take a piece of code, you say, I want this to be executed, I don't care how. I don't want to see it again. Then there's a future, which is a background calculation like async, but it returns value back to the caller. So this is a big difference if you just want to submit something and forget about it, or if you want to get some result back. This one is easily done with tthread. This one, less so. Passing data back to the thread, to the owner, is not something that is implemented in the basic framework. Then join is extension of async that executes multiple tasks. You say, I want this to be executed possibly in parallel. If no, execute sequentially, whatever. All those constructs, they are dynamic. They will check how many cores you have in the system, how many your process is allowed to run on, and they will distribute the work accordingly. Parallel task is, again, similar to those, to join and async. It works on multiple cores, but it executes only single tasks. So you say, I have this piece of code, run it in parallel on as many processors as possible. Then for each is the parallel for. Interesting topic, but maybe not very useful, it turns out. Pipeline is very useful in practice. I will spend lots of time talking about it. Basically, it allows you to take a sequential process and do a partial parallelization out of it. And fork join is something that's designed more for computer theoreticians, for people who write graph parsing stuff and quick sort algorithms and so on. So implements a framework which you can use to parallelize algorithms of the divide and conquer fashion. Those are the algorithms when you say, okay, I will split this in two parts, calculate both, and then merge results back. And for, I said, OmniThreadLibrary works on Delphi 2007, but all this high-level stuff requires Delphi 2009 because it's based on generics, it's based on anonymous methods, and these are simply not available in 2007. So, get a drink, continue. I will move to practical demo now. And before I start showing each part of high-level constructs, I have a small explanation in the beginning. So all this stuff is prefixed by parallel dot, mostly to not pollute the namespace. So async and join, and for each there are such common names. It's quite possible somebody is using them in the code already. So you always have to put parallel dot something in between, in front. So ASIC takes a code. This code is, well, it is anonymous method. In the ASIC is declared to accept an anonymous method. If you want to know more about anonymous methods, you are invited to my last session tomorrow, which will go in depth with this. But for now, let's say that Delphi compiler allows you to use a normal method or even a procedure that is a code which is not a part of an object in place of an anonymous method. So you can put here some method or some procedure or in place code, an anonymous method, and it will be executed. We'll see this in the demo. And what it does, you call async, and it creates a new thread. This bar is a thread delimiter, and it runs this code in a secondary thread. And this code will stop at some time and get destroyed, and this caller doesn't care what happens to the code. Okay, so this is simplest as possible. My first demo with async was parallel.async call message beep. So it would beep, but in secondary thread. Not very useful, but it worked. So I have a program here. Because I cannot type all this stuff, it takes too much time. I will run it anew. This is running in XE2, just so that I prove that it works in XE2. I have a timer running which updates the progress bar. And this is just the visual indicator, so we can see when something is executing that blocks your program. So I have here a HTTP GET call implemented as a simple synchronous GET, so it will stop everything. It will fetch a page from the web server, and as you saw, the green bar was not moving at the time. For comparisons, if I call async version, it will call, I'll show the code in a second. It calls the same function, but nothing is blocked. So let's see some code. This is all the stuff around is just time measuring and logging and so on. So this synchronous version just calls HTTP GET, which is a simple win inet call, which gets one HTML simple. So what do they do? What do I do to convert this to multi-threaded version? Well, I call parallel.async. And in this example, I wrote a simple anonymous method that calls HTTP GET. So this is the code, sorry. This procedure is something that will be executed in a background thread. This is our task. And this task calls HTTP GET, gets back a page, and throws it away. Because this shows some of the problems with the async. There's no built-in communication in the high-level stuff. So how do I get this content of this page back to my main forms? So basically, I have three options. Let's see. What do I have here? 1 second. Sorry. One option is to get the page and then do something similar to Delphi's synchronize. I can say invoke and execute some code back in the context of the main thread. So this will be executed in a background thread. This will go back to the main form and will be processed there. So to prove this, I can put 2 breakpoints here. No? That's Delphi. Sometimes you cannot put a breakpoint. It will work now. So at first, we are here in the background thread. It has a nice name, parallel.async, so you know what you're looking at. This is done automatically.